Mic works. PowerPoint works. We're halfway there. So quick introduction. Adam Fishre. I've been in IT security for a long time. Flew in from San Jose today, spent half my week on a plane, if not more. Have, like most people, have really turned my focus to cloud solutions, and a lot of my customers that I work with now are, AWS, Azure focused, or are moving there in some shape or form. Originally from Pennsylvania, came out to Salt Lake City in 2001, graduated from Utah Valley University, met a Utah girl, now I'm from Utah. And insecurity because of WinNuke 95 and ICQ. So when I say WinNuke 95, and every time I present and every time I ask this question, the hands get less. Who knows what WinNuke 95 is? 1, 2, 3, 4. It's getting less. No WinNuke 95? Oh, okay, that's good. So WinNuke 95 was a great tool that would send an out-of-bound packet request to a Windows 95 machine and cause a blue screen of death. ICQ was a chat protocol, probably some of you are familiar with ICQ, that gratefully exposed the IP address of your person you're chatting with. And it was often fun to watch those people just drop out of chat rooms left and right because you just take their computer offline. And so that really got me into, all right, this is some cool stuff. The fact that I could be sitting remotely, in my house, and I could take somebody offline, other side of the world, other side of the country, out of the state, whatever it may be, was pretty appealing. Today, we're going to talk a little bit about a new attack vector that I would say has gained a lot of exposure over the last 18 months. It goes by a couple different names. We got credential stuffing out there. It can be referred to as account takeover. Really what this is an evolution of password theft down at the gate. It's just stealing people's passwords and reusing those passwords to take over their online accounts. And that's what we're going to review today. We're going to go through a couple threat patterns, why it's important. We're going to look at a tool that can then be used to launch these account takeover attacks and what it takes to mitigate those attacks from a security perspective to protect ourselves. So first off, kind of setting the stage here, online accounts are valuable, obviously. If you think about all the websites that we log into, what would happen if somebody else had your account? And we're full of examples of what happens when people drain your bank account, take your reward points, get to your financial data, and those accounts have value. The three main avenues that we see is data breaches, and we're all familiar with those. The other way that we're going to get, or somebody would get your account, is malware keylogging. They install a virus or malware on your machine, and as you visit those sites, they take your credentials. And then phishing, and we've seen phishing attempts. By far and away, the most common here is data breaches. I do have just a little slide here on that, but this barely touches touches the front door, just breaches the surface on the amount of data theft there is here. It seems like every week, we see businesses that have exposed customer data and exposed those login credentials. And what the next step here isn't so much that, I have this breach, I'm then going to go and log in with those accounts. The idea is to sell those. Right, so once we have those accounts, we're going to sell them. And there's various sites out there that can be used. This leak source is one that is pretty popular that I see. It seems to have a lot of good stuff on there as far as once a breach happens, leak source tends to be like one of the first ones to expose it. Now, what's interesting is by the time we see those leaked credentials come up for sale, they've already been validated. They've already been used. If somebody's selling them, it's usually because the hackers that already had them went through, got what they could out of it, and okay, now we're going to sell them to get the last little bit of money we can out of our breach. A good presentation is nothing without a few numbers. And out of the Google passwords that there are, the latest one I saw here from Google was 67 million passwords. Now, even me being in security, I have no shame in admitting this, I reuse my passwords. Not every single one. But I have a number of passwords that I'm just going to recycle through. That way, when I forget my password, I can usually get it within 4 or 5 tries. And that's about as long as I can go before you're locked out, and then you're really screwed, right? And I'm pretty sure everybody else in this room, I talk to enough security professionals, we all reuse passwords in some one shape or form. If you don't, maybe you have like a password manager or something, hats off to you, that's great. I still don't find that works across enough of my devices. And I get LastPass is pretty good at it, and if you buy into the Chrome atmosphere, then that can do pretty good across multiple devices. But nothing frustrates me more when I actually did set some super secret password that only my password manager can enter, and then on my mobile device, and I can't freaking get into the site. Once that happened, I was done, and I was like, that's it. Now I have a handful of passwords that I rotate through, and usually I can get to it in about 4 or 5 guesses. So we're all guilty of that, and that's why, when we see this as we go through the Hydra tool, why it makes sense that one, attackers are going to spend time to get to a set of usernames and passwords first that they know exist and know is being used, and then second, that's what they're going to guess with. If I'm a real attacker, for me to launch an attack against a website and cross my fingers that I'm going to get a username password combination, though it may be successful, is going to cost me a lot of money, a whole lot of time, and by the time I get to it, it's nearly useless. So I want to start from a known set of identities if I'm going to get to the data that user account has access to. So in the next couple slides, I have some examples of real data breaches here from a tool that I have access to. And we're going to walk through this console in more detail here later. But just to show you kind of how an attack, how an attacker may think as he's coming through here and launching an attack. This is a tool here that specifically monitors login activity for that malicious activity here. And so the first thing, the gray box here, this is just login attempts, not necessarily malicious or anything, but login attempts. The yellow line then are the ones that are deemed malicious, and the blue line that we see catching up here is when the algorithm kicks in and it starts blocking attacks. So this is pretty standard from, somebody's just launching a wave of attacks, and you'll see this kind of ramp up usually during a reconnaissance phase. So what I mean by that is it's slow, it's steady. They're just trying to see what security tools are in play here. Is there any rate limiting going to happen? Are you blocking countries? Anything around the gamut, right? So they're trying to get some feedback as to what is going to trigger one of your security tools to mitigate the activity. After that, you're going to get into what I call spikes. All right? So now they get a feel for what's going on, and they're going to ramp it up. Okay, now they want to see how fast they can get through a list before the rate limit or something kicks in. By this time, they have already created 5, 6, 10, 12 legitimate accounts in your website. If it's an e-commerce site, they've already gone through the login process with legitimate accounts a number of times. They've even purchased real things or signed up for real services a number of times, so they have the complete flow of what they need to do once they find a legitimate account. So now that they have that, now they're going to see how fast they can get through it. Okay, and you're going to start seeing them ramp up. Now, from a security perspective, we love lots of data. We love lots of anomalies, and that's what happens when things kick up. So what you'll see are some of the spikes here, and we'll see this when we launch an attack here, is most of these types of tools will allow the first 20, 30, maybe 40 requests in, and then start shutting it down because the algorithm starts picking up on those anomalies. And then you're going to get something like this. So yeah, I'll back up here actually and just talk about some of these numbers so you can see the scale of the attack. And I'm not sure the numbers show up there because they're kind of small on my screen. But we had here within a 7-day period 15.4 million login attempts, out of which 15.39 were deemed malicious enough to be mitigated. That's a lot of logins for 7 days. Okay, that's a really busy site. And this wasn't like an Amazon site, right? And so this is what, so when I talk about ramping up, this is ramping up. They're going to start sending multiple requests. And then you'll start seeing it level out, and they're going to get to a point, they're going to basically get to a point where they can send as many requests as possible where it's under your rate limit and it is not going to take down your web server, right? And so now this levels out and they're sending about 2 million, So we'll see things like that. And then on a normal day, this is what you should see. Everything's green. You have that nice bell curve that we all see in our network graphs. People go to bed, then they wake up, then they go to bed, they wake up. And that's what we expect to see from normal login activity. Okay, so let's get into this here. How does this happen? First off, they have to breach and harvest the credentials, or they have to go and buy credentials from somebody else. And we'll get into why you have to do that. There's no way we want to start a credential attack from ground zero. The next thing you need to do is send this through multiple proxies. You're going to either have to own a botnet, rent a botnet, but you cannot launch an attack from a single IP address. Once you gain access, so we're going to log in 1 million times. We hope for 100, 200, 1,000 good hits. Out of that, then, we go through the login process. The control server, the bot network then knows how to manipulate the site to get the end game. That's either to take the medical records, drain the account, steal the funds, drain the gift cards, whatever it may be. Fraud of some sort. And that's exactly what they're after. Now, some accounts will actually stop at step 3, and they will have the breach. They're going to get all these accounts, and they're going to target a specific company, a specific site, a specific bank. One of the worst customers that I saw here was a very small regional bank out of St. Louis. Normally, they might see 500 to 600 logins on their site a day, and all of a sudden, it was in the millions. In the millions. And, I mean, their poor guys were flooded to death, had no idea how to handle it, but it wasn't so much that they were after the records or after those bank accounts. They wanted to know which logins were successful, and they were taking those and then selling those out on the dark web. So their job was, we're going to take all of the breach data that we see and just see who's reusing that Gmail, email, and password to log into this bank site. And then that was enough for us to go out and say, hey, here's 600 accounts that can log into that bank. And that for them was the asset. So there's oftentimes two ways you'll see there. I personally feel, and what I've seen is the steal asset methodology. If somebody's after what's behind that login, they're more sophisticated. They're not going to go away. They don't give up. For them, the end game is that medical record in the healthcare portal or whatever it may be. Okay, they're more sophisticated. So if your website is protecting or has access to that type of data, just expect to have a more sophisticated attack, and we'll get into some of that. Okay, I'm going to go through this. I'm going to go through that. And then this will be the end game here. So after this, we'll jump into the demo, and we'll start walking through Hydra. But eventually, this is what's going to happen to your data. it's going to be distributed. It's no longer going to be coming from, a single IP address or a handful of IPs. It's going to be globally distributed. So you can't really hone in on it or target it. It's going to be on a login page, but then it's going to be a very slow request rate. We're talking 1, 2, 3 requests per IP, and then they're off to the next IP address. And why do they do that? Because they don't want there to be a spike, a noticeable spike, than your normal request per second traffic. It has to blend into normal daytime bell curve traffic. And you'll see that. You'll see them mask it so that it just is part of your busiest time of the day. All right? Okay, good. So I'm sure I've been timed out of 90% of my stuff. But the first thing I'm going to do is just introduce us to Hydra. Now, Hydra is a credential stuffing tool, for lack of a better description. It allows me to define a website, define the usernames and passwords that I want to use to then try and log into that website. It requires a few bits of information, and we're going to walk through that. So first, a single target, or I can do multiple targets. I can have a text file of URLs that I want to attack. So I put my URL in here, I put the port that I want to attack on, and then I want to put the protocol. Now there's lots of different options here. I could have chose to try and brute force an FTP site or an SSH login. I could try and brute force an edge firewall. They got Cisco in here. All that kind of good stuff. So we're not going to focus on all of that. We're going to specifically focus today on HTTP post. And that's simply because the website that I have needs post, right? Required a post form. So what we have here. Thank you. That's weird. Let me try this. Sweet. Okay. All right. Good. Thanks for letting me know. All right. So where I'm at here is, So I'm going to jump ahead a little bit. Everybody should see this site. So if you're out there and you want to browse to fishhatchery.net and just start clicking around, that'll give me some traffic. Don't DDoS it or break it or anything, please. At least for the next 45 minutes, then you're free. Okay, but what we need to do here, so if I'm an attacker, I'm going to use Hydra. There's a couple things I need to do. So like I said, I need to go through a login. I need to know what the login is going to look like. The first thing I'm going to do is come into DevTools, I'll refresh, and I'm going to basically pull down the information for the site. I've got a login button here, and some sites are like this, right? When I do this, it brings up a form, but I don't see the login, where the login request is going to go over here yet. So when I log in, I then get, where am I at? I get spinny bars. So what I'm after is the login PHP. Let me just refresh this. Make sure I type in the password right. So the login PHP is what I want here, and we can see that this is Ajax and then login PHP. This URL is where the request goes. And so this is the request that we need. So if I'm going to do this with another site, this is what I would have to go and pull off. Okay? The request is a post. This is what I want to get to. So I would take that then in Hydra, and I'm going to add this to my specific URL path here. So I want to make sure people see this. That's the first step. You have to grab where that request is going to go. And as an attacker, this is part of my reconnaissance that I would do on any website. The next thing I'm going to do here is define my usernames and passwords that I want to guess. So if I am specifically going after a known user, CISO, CEO, CIO, somebody famous, right, that I want to try and grab a username for, I can drop it right in there and just try and guess passwords against a single username all day long. Here, I've taken some of the things that Kali gives us. I've taken the RockU username list, and then I've created a password list. I'm going to get into what I use there to do that, to create a list of passwords that I want to guess. If you choose Hydra to allow it to generate a password list for you, you can use that. It limits it at 4 billion passwords. You may think, oh, that's like more than I'd ever guess. It's not hard. An 8-character password of lowercase numbers would be more than 4 billion combinations. So it's not easy to do that. So I use Crunch to generate a password list for me. And obviously it's a lot easier. Crunch can generate X numbers. So why is Crunch helpful? So I'm just going to do a quick one here. I won't necessarily use it, but Crunch, I can do something like this. Start at 8 characters. So if I know the website, part of my reconnaissance, if I type in the wrong password, what do most websites give you? No, it has to be, 8 characters long, uppercase letter, special character, whatever. I can actually take Crunch and I can put in those variables to this site, exactly what I need, right? So if I need it to have a special character letter, I can just start typing things in there like that to match the password requirements of the site that I'm attacking, okay? So for me, that admin password is webco123. So I can put in those requirements. Now it's not going to create just that password. It's going to create every combination that those letters would create. But now if I wanted to say, I know that the password's going to end in a number or a series of numbers and it's 8 characters long, I put in 5 characters and then I say it's going to end in 1, 2, 3. So now that password list is already smaller. And this is exactly what an attacker would go through as he wants to limit how many guesses he needs to make before he's successful. Now this list right here still created something like a 128 megabit file of like 8-character text on each line. It's a lot of guesses. And that's why they have to ramp up an attack. They can't just do a little bit here and there. It's got to be, they have to max out how fast they can get through it. And then I will just simply output this to a file text. I think I got this syntax right. Oh, what did I miss? The max min. Maybe I have one more in there than I should. All right, there we go. So this is going to create 32,000 lines. There it drops through. Doesn't quite look, oh, because I have 1, 2, 3 in there. But you get the idea. So what I did here then is I basically just created a list of passwords that's going to run through various combinations of that webco123. If I can also create a specific username password, and that's what I have here in the root final. So we're actually going to go through an example of that as well. All right, some other things here, tuning. I think this is the one I had, yeah, so I tuned this up a little bit to generate some traffic. And this is where you can turn a credential stuffing attack in from, I'm trying to guess usernames and passwords, to where I'm trying to crash the login server or the authentication process. You can really ratchet this up. I was able to get off of, my simple Comcast connection at home. If I set this to 64 and the timeout down to like 10, I got about 20,000 requests a second out of a single process on a single server from a 10 megabit upside connection, right? And that was pretty impressive. That kind of gives you an idea of just how Hydra, how fast this thing can run, okay? We're not going to do that now because it prevents like half my internet from working at home. So I'll put this down to like 16. It's a little bit more of a reasonable number. And then if we have time at the end, we'll have some fun and we can crank it up. You can if you have a single proxy, you can proxy this right here, but we're going to get into a better way to do proxying. So let me switch over to this screen here. I'm going to start with this attack, and it's a little bit less. And we're going to get rid of this to start. Okay, the next thing you need to do, so just like those usernames and password fields that are there, the query parameters, we need to enter those. And there's a format here that you can read about with Hydra, basically username, user, password, pass. And then Hydra, it doesn't look on what's successful, it looks on what's false. So it wants to look at what is an invalid login. And let me come back to my site here, see if it's acting a little bit better. See, I actually think I gave it a headache for a while because I was hitting it hard to give me some data. Let me see here. If this doesn't work, I'll just jump to the login. Yeah. So let me do this. And you'll see what I'm talking about when I say like a login, like the login response. So if I come straight to that page, then that's what we're after there. So here, I'm just looking at the response from a failed login. This is what it would send me if I try and hit the Ajax login.php without any username and password. It's just going to say invalid username and password, and that's what I'm looking at. So so an attacker would need to gather this as part of his reconnaissance. That's why he's creating valid accounts. That's why he's going through the login flow, so he can differentiate between what's a valid and an invalid login. If you don't have that, Hydra is not going to be able to tell you when you hit gold mines and when you hit a valid login. Okay, so you have to be able to feed that intelligence back into Hydra. And really any other account takeover tool you needs to be able to differentiate between a valid and an invalid login. So some of my customers have tried to obfuscate that piece of the puzzle. So they'll do funny things like send it for a redirect to a different site, or they don't have any indication that it's an invalid login. So if you log in with a valid login or you log in with an invalid login, the response doesn't differentiate. It's the exact same. And that's a good obfuscation technique. A hacker who's persistent isn't going to stop at just that, but it does make it more difficult. So think about that, right? If you're managing your website and your logins, if you make them both the same, both responses are 200s, everything says it's okay, and everything's the same, it's difficult to differentiate from an attacker perspective when I'm successful, okay? Because surely he's not going to sit there and look at each aspect of it. All right, so let me look here real quick. I think on this one, now this one should get blocked. I'm not doing anything here to really hide myself. So what I'm going to do is I'm actually going to use a separated one. This one runs through about 20 different combinations, and then it does have a valid login here at the end. But this should still be detected. So what we're going to do is we're going to run this through Impervious Cloud Web Application Firewall that detects these sorts of actors, these sorts of tools. Okay, so out of the gate, Hydra, because everything on Kali, right, is not to be used for malicious purposes, identifies itself as such. It's going to tell me, hey, Hydra is visiting this website. It does not hide itself, and we're going to see what happens. Okay? I don't want to send it through proxy chains just yet, because then I'm hiding myself. Let me, I think it's this one here, I can use that. But let me get rid of my header. Okay. Still valid, make sure my tuning's right, yes, good. All right, we'll start this one. Now I'm going to run, now I have this one set for sorry guys. I have this one set to go through. I want to go through you. Just so it's a little bit shorter and nothing too Nothing to hide us. This is going to be a dry run. No, open it. I type X Hydra in the Kali terminal. This pops up, and here we are. So here we get to see the logins that I'm trying, the passwords that I'm sending. We come down here. Everything's done. 0 valid passwords. Everything's complete. Everything's finished. So I've been running this right here. We can then see everything was blocked. Red line means blocked. About 35 requests a second. When I come down here, look at new samples. THC Hydra detected as a bad bot. This is exactly what a web application firewall is designed to do. From this standpoint, if you don't have a web application firewall, you're missing the first boat. Okay? If you're not blocking this, you're in big trouble. We haven't even gotten into an advanced persistent threat scenario yet. This is an out-of-the-box script kiddie. Your guy down the street installed Kali and wants to play around on your website. Okay, that's what this is. 206 requests, 206 blocked. And you can see Hydra right here. This is the user agent. Accurately identifies itself as Hydra. So if I am an attacker, any guesses, what's the next thing I need to do to be successful? Where should I elevate my procedure from here? What's the next tactic? I'm using some keywords here. Yeah? Yeah, you're cheating. Yeah, you can't comment on this one. You know the answer before I even ask the question. Okay. So, yeah, right. First thing I need to do is change the user agent. How hard do you think Hydra makes that? Very difficult? Probably not. So what I did is I went out to this website here, super secret website, Chrome user agents, and I can just look in whatever user agent I want to pick to make my user agent look like Chrome. I can just pick a version, right? Let's go for 74. I picked 74. I'll use GIM because I like to. I'll drop my user agent in there. H for header equals I define the user agent. I have to escape the colon, and then I drop in the Chrome browser user agent. All right, not very difficult. Pretty easy. What do you think the WAF's going to do? Thoughts? What would a web application firewall do at this point? Let's find out, okay? So now we're going to run it, going to go through those same username and passwords, only this time I'm sending a different header, classifying myself as something different. All right. How about now? So now, as expected, same IP address showing up as Chrome. I expect to see a little bit of a spike here. Sometimes it takes a moment. Oh, I know why. I'm a little step ahead too. So this was something else I was doing earlier. Just so that, again, I'd have some data, but I got to turn this piece off. And we're going to turn this off. Come back here, we'll trigger this again. But yeah, as expected, you can see there now I'm showing up as Chrome. But there's something else here that this is going to trigger on that an attacker would not like. Because even if a web application firewall will eventually trigger on this. It will not be difficult for the firewall to block this attack here either. So let me come back over here, see if we can get some data now. Probably need to give it a bit for that other mitigation rule to slide away. That's why we were seeing this right here, so this mitigation rule. And we'll get into why that's important and the next step that you would have to take and why we're seeing those specific types of solutions in the market today. Well, so I've seen this happen once or twice before. And if I close Hydra and open it up again, it kind of like refreshes itself. But I have another one over here, and we're just going to proceed on. So what's going to happen is the next thing here is what we're going to see is every attack still comes from a single IP address. So even though now I don't have Hydra here, and I have my Chrome user agent, which means I'm no longer going to be detected by some signature, some bot classification. I now look like a browser. I'm still coming from a single IP address. And that's not going to work. A couple things are going to happen. First off, if you're really launching an attack consecutively, that IP address is going to get blacklisted in a matter of 24 hours. You're done. You have one day. Okay? So you're going to have to distribute this. How would you distribute this? Cheaply and easily. Thoughts? Say again? Ooh, I didn't expect that to be the first answer. That's a good one. So proxies. All right, next, Cali guys. Let's be more specific. What tool do you think I used to go against proxies? Yeah, thank you. Might have given that away in the beginning, but that's a good one. So the first one thing I liked, and I really like this list, it was pretty accurate. Proxy-list.download is a glorious site where you can go out and in a click of a button, if I want to get through all of these different proxies, I can pick the country that I want, or I can just, look at this. I can come down here and just click in the box, and it copies to my clipboard. And here I got a list of SOCKS 4, SOCKS 5, HTTP, HTTPS proxies. How many do you think are here? For free, updated every 2 hours. 10,000. I'm not even paying for a botnet. I'm not even controlling a botnet. I'm browsing the internet and I have access to a free list of 10,000 proxies. Okay, so what do? I take all of those, I drop it into Notepad++, because I need to massage it a little bit. Proxy chains, the program Proxy chains wants to have tabs instead of colons, and you need to define what the protocol is for that proxy. So we do that, I copy it over, I add it to my list. Pretty sure I have. Oh well. I have it in my proxy chains config. And here it is. I got 4,649 SOCKS 4 proxies. Okay? So let's take a moment and we're going to talk a little bit about setting up proxy chains. Nobody can talk to me about Mr. Robot because I've only watched the first episode, but they do this. Elliot does this in like season 1. And if anybody talks to me about episode 2 or 3, we're done. But he does this in like season 1. He uses some proxies out of Estonia and uses proxy chains to mask his content. So the first two here, dynamic and strict chain, those are good if you know exactly what proxies you want to bounce through. Meaning I've got 10 proxies that are nowhere up and fast, and I want to go through those from proxy 1 to proxy 10, and proxy 10 is my exit node. Okay, those are good. Strict means 1 through 10 have to work or else you're done. Dynamic mean if 5 is down, I'll just go to 6 and you'll have 9 in your chain. Okay, but this is literally, we're talking about that spinning globe and you're bouncing across the globe to different proxies. That's what proxy chains does. What I have set here for is round robin. I've got 4,000 some proxies. I don't want to go from 1 to 4,000 before I actually get to my target. This is going to basically just cycle through a random list and pick some. But what's nice about this is that if it does find a dead proxy, it won't use it again. All right? And when I tested this, I created my proxy list like last Friday. And when I tested this at 1 o'clock today, I had like a 90% dead rate. That's how fast these proxies come up and come down, and you need to keep it refreshed. And it's important to then to skip out the dead ones, and we'll see that here when I turn this on. But there is the chain length setting here. If I set this, right now this is set at 2, so I'm going to use 2 proxies. If I want to be more, I can make it whatever number I want. I've got 4,600. I won't go that high. But be aware, if you set this to 4, 6, 8, or 10, like I've done before, then you must set your timeout. Where is it? You must set your timeout here to be equal to that. If Hydra doesn't get a response in 30 seconds, it just closes the connection and goes on to the next request. So if your proxy is long and it's going to take a while, you're going to have to wait a while, right? So that's what it's going to take. And I'm going to leave things on verbose. It'll be really chatty when we run this. It's kind of nice to keep, don't print message errors unless you really care about, how much closed connections and stuff you have. So I think I'm happy with this. I'm going to get rid of this. And this is like 44 billion combinations here, so we'll let this run. I let this run too long on Friday. And then we'll drop in the user agent there again. So we'll get past the WAF. We'll start this. So now we see proxy chains. Oh yeah, I forgot this point. I had to upgrade proxy chains on Kali to 4. 3 was not stable. It wasn't connecting through proxies. I couldn't figure out why, and I just upgraded it. And amazingly, that made it work. Okay? So here we go. We're going to let this run a little bit. And if this bombs out on me, I'll have to close it and open up a new Hydra. It shouldn't be stopping here at 16 like this. I'm probably not getting any traffic. Okay. So I'm going to close this, and then I'm going to have to add everything back in. Just give me a second. Should be like right there. So that's how you start it. Then it opens up, and you can probably have it like saved and stuff in here, but I just haven't. But it's not that hard. So my username list, my password list. Tuning will leave it default. And I typed this in and left that. Unfortunately, I know it. But I don't know this. Okay. All right. Wait a little bit for my restore file to go away. it's getting stuck. This should be running through that. Always the joys of a live demo. I'm hoping in like verbose mode here will just give me something. Usually it's pretty helpful to tell you what's going on. Here. Let me see if I clear out my restore file, but I don't think that's really the problem here. All right, one more go. Give me some love. Well, as that's sitting there, we'll let that think for a second. When I ran this before at 1 o'clock, you can see here where I was coming out of. All right, so you're going to get these requests. What we're going to look up, and we start showing up here as basically unknown bots or pingdom bots. And this allows you to have a much lower request rate per IP address. So you're going to have, traffic that looks a lot more simpler to normal traffic. So where do I go from here? If I want to detect this style of traffic, I can't rely on signature-based policies. I can't rely on simple classification. This is where solutions in the market have come out around what's referred to as advanced bot protection. So solutions like Distill, Shape, anything that says advanced bot management is where we have to go to get here. So one of the solutions that I have on hand is Impervious account takeover tool. So you can see today when I ran this, I cranked it up pretty well. It's probably why it's not working right now. But just in that short amount of time, I had 200,000 requests come in, out of 202,000 legitimate attempts. We can see here where this was, and then when I enabled mitigation, what happened? We got to, pretty much an exact match on the attacks that I was running. And the account takeover solution takes it a step farther. At this point, we're not looking at user agents. We're actually looking at the behavior of the logins that are coming in. And it's a lot, I can't even get into the algorithm, but simply to say it's machine learning. At this point, we have to get into some type of machine learning, behavior profiling, risk-aware situations where it's not looking at each individual request on its own. And so when we enable mitigation, this is what we see here. We can see what things are classified as, some of the places where I'm coming from. You can see a few of the countries where, even though most of us still United States, some of those proxies were located elsewhere. And so this is where I'm coming in from. And this is a style of a solution that's specifically geared toward this style of an attack. And so you might think to myself, why isn't a WAF or why isn't another security tool capable of admitting this style of an attack? And it's because it's legitimate traffic. Login by nature isn't a SQL injection. It's not a cross-site script. It's nothing inside the OWASP top 10. It's not even bad code in my website. It's just a login page. It could be coded completely 100% correct. But it's still a hole into the application that's being executed, being breached. And so we have to look outside of the standard code vulnerability style tools. We have to look outside of the standard application security tools to a specific solution. And so that's where the account takeover market really is right now. And it's all possible because of the machine learning that exists. You got a question? So the mitigation here in this solution is kind of based on probability. And we take it, there's simply a risk associated to it. So, and when you get into the risk aware, it's not a yes or no. So we have the high attack probability, medium, and low. And so, and obviously the high attack probability, there's a point there in the risk rating where it turns into high from medium. And there's no simple answer to say, oh, it's because we saw X number of requests or X number of bad requests. It's a holistic view of it comes from this IP reputation, it's classified. You know, a lot of what we do is we see like AWS IP addresses. Well, if you're being attacked by an AWS IP address, it's probably not one of your customers who fired up a EC2 instance to log into your website, right? And so when we see that kind of activity, it raises the risk, right? And that's what you're after. And so the main thing here is you really need to look at risk aware. You need some type of an intelligence that says this is what's causing it to be an elevated risk. And so along with that, lots of times I'll show this to customers, and you know, there was a large rental car company I was working with, and you know, what some of their first questions are when they enabled mitigation is, why this slope? You know, and that's because we have to actually do there's a little bit of learning involved. You know, if we don't have a slope, then it's a yes or no discussion, and your false positives go through the roof. You start blocking legitimate people logging in. So there has to be a learning, there has to be that time where the algorithm can hone in on what's risky and what's not risky. So the fun part here, the climax of it, looks like it's going to bomb out on me. Let's see if we can get a little bit of luck here. I might have to do a restart here. What is this doing? I come back here, nothing. I'd say like, is my internet down, but I'm like VPN'd into my router right now. So I tell you what, I got like 5 minutes. I'm gonna do just a quick, I'll just restart this whole thing. And then we can, I'll take any questions. This shouldn't take too long. We can try it again. But really what Proxy Chains does is it runs through every chain link that I have and launches those attacks. Yeah? Yeah, absolutely. So you definitely need to have that. What I did here is I went back 7 days. We'll go back a little longer. We'll go back 30 days. So you see this, what I'm highlighting here right now is a list of compromised user logins. This is a list of accounts that were successful during an attack. Okay? So this will come up here. Give me some love. And then we'll be able to see which usernames were listed here. So this will be all stored on the source IP, and this will actually provide to you the usernames that you would then want to go and take back and give to your, give to your fraud team. They say, hey, these are the passwords that we need to reset. So let me try this here. All right, so here we can kind of see what shows up. Googlebot Impersonators. If I take this, we'll just see the ones here. So I was successfully logging in as admin. We provide those usernames. And this will show up. What's really nice here is that these will be, filtered out during the attack. So we'll see which ones were successful. Mm-hmm.
So once it's learned an attack is going on, does it go back in time to determine if there was, some things that maybe happened before to create that list?
Absolutely. So there's that learning mode when it ramps up. So the algorithm's still kicking in. Once the algorithm catches up, so for me, basically, if I set the blocking to be on high, I shouldn't see any compromised user logins in here that are listed as high. It should only be maybe medium and lows that were successful. If I come back in here after the fact, we will retroactively raise the risk level to these if in the future it was determined, oh, that was actually high. And so that's a very good point. So my customers will leverage this. So that example that I showed previously with 15 million attacks, out of that, there was probably 2,000 that we might say, hey, these are probably compromised logins. What they do is they come back in here, sort that on high, and those were the ones that were retroactively elevated. Those get sent to the fraud team immediately, proactively force a password reset, or just use that intelligence to possibly increase the fraud score into other solutions. So with Impervious solutions specifically, this sits at the edge. It's a cloud WAF, just like an Akamai or Cloudflare solution. And it's oftentimes the very first solution to have visibility into the attack because it's on the edge, closest to the edge user. And so because of that, you can then feed that intelligence into downstream solutions. Okay? Yeah, so that's good. The other thing here, that as you're evaluating account takeover solutions, you definitely want to look at lead credentials. This is another thing here that we provide. This is something you can go out and say, hey, look, here are, we have a list of, billions of breach credentials from various breaches that are out there. It may not even be used in the attack, but if somebody just logs in, we can notify you, hey, that person's using credentials that he also uses on Marriott and eBay and LinkedIn. You might want to have him reset his password, right? Those are two key things, especially the leak credentials. If you're looking at ATO and you have a solution that doesn't have that, just keep looking. You need to have that type of intelligence. So this is what I launched like last week when I was messing around with this, getting ready for this. So appreciate the questions. Let's see if that bought me enough time. We'll try this one more time. Holy smokes. That sounds like my kids probably watching Netflix or something. All right. Now, obviously, you don't have to use Hydra, but obviously it demos pretty well, except when it doesn't work. Oh, yeah, thanks, man. You know what, for this one, let's use one that I know will work as a working credential. All right. Well, let's just go with that. And if that works, it won't get around Hydra, but we'll see how far we get. And then I can just disable some protection if This will get through the first 16. No, yeah. There we go. Okay, so I got the round robin working. Let me go grab. I need my header value real quick. Really difficult to find these things. I think that's the thing that's most surprising, right, is people really feel that to launch some attack like this, I have to be, it's super complicated, and all the data is hidden underneath some magic rock, or I don't know. But that is not the case. All right. Now we should have some data when that thing kicks off. Yeah, we already had some stuff in there. And just want to make sure. Yeah, okay, good. Otherwise we won't get too far. All right, so I'm at 4:30 now. We'll be about done here. I'll let you guys go. So this is going through the connections right now. When it keeps saying okay, it means it's good, it's good. It should keep going, there we go. And now we're cooking. So this will be your chain. This is just picking up 2 random IP addresses. And right now it looks like, so I did update this about 2 hours ago, my proxy list. So I'm not seeing the connection timeouts and drop connections that I saw before, which is good. And this will show up here, but the connections take a little while. Yeah, and so what's interesting is it goes through all of this, and it'll just keep going. And you got 4,000 proxies to go through, and now my traffic, everything's hidden. It doesn't detect the user agent. It doesn't detect what IP address I'm coming from. My target will now see IP addresses coming across from every which direction, and you're totally obfuscated. Didn't have to buy a botnet, didn't have to own one, just going through a bunch of SOC 4 proxies. Any questions on that, or what we talked about? Yeah? Cool. Well, I'm at time. I'm still not getting traffic over here, but I know that I will. The idea was to have that running for a little while, so we would. Any other questions? That's Hydra. Be safe. Don't hurt yourself. Okay, guys, I appreciate your time. Thanks for your questions.